Homework S1, question 7. We've got a sketch of a function, fx, and a couple of key points have been listed, 5, 4, and minus 5, 4. Sorry, minus 5, minus 4. And we've been asked to sketch in separate diagrams the functions y equals modulus of fx, y equals f of modulus of x, and then y equals 2 lots of fx plus 1. So on the first one, y equals the modulus of fx, the modulus makes anything negative positive. If it was positive to begin with, it stays positive. If it's negative, it becomes positive. The effect that this has on a graph is to reflect anything that is negative, positive, but to keep the positive parts the same. So this right-hand side of the graph is going to stay identical. I'll try and do as close a sketch as I can to the one that's above, but it is only a sketch. And that's going to stay as it was. So the point A remains as 5, 4. However, this part that was negative now gets reflected. So this point of inflection now becomes a minimum. We still have another point of inflection here though, and that minimum of minus 5, minus 4 is going to become a maximum. The x-coordinate stays the same, but the y-coordinate has changed. So that is my new graph for part A. In part B, I now have to sketch y equals f of the modulus of x. So in this case, all our x values are going to be made positive before we plug them through the function. Now, when we're dealing with positive values of x, we are going to make positive values of x stay positive values of x. So once again, the right-hand side of this graph is going to remain identical to what it was before. So I head up to my maximum point of 5, 4. And I come back down again for the point of inflection here. A is still 5, 4. However, for negative values of x, they are going to be made positive before I plug them into the function. So minus 1 is going to behave as if it was positive 1. Minus 2 is going to behave as if it was positive 2. And the effect that this has is to do a reflection of the right-hand side of the curve going in. So I now have a mirror appearing down my y-axis. So this is going to come up to give me my maximum point over here again, and then come down and intersect with the x-axis. That point B is now a reflection of what A was, so just making the x-coordinate negative, it is once again now minus 5, 4. In part C, I don't have any moduli, but I do have to sketch the function y equals 2 lots of fx plus 1. This is two transformations taking place, and it's often easiest to just do them one at a time. So I've redrawn my original graph, and I'm now going to do the transformation of f of x plus 1. This has the effect of translating by one space to the left. So my point of inflection is now occurring here instead. I'm rising up, coming back down again, and I've still got a second point of inflection leading to a minimum value here. So I was only asked to do the coordinates of A and B, so I don't really have to worry about this one where the origin is moved. But A has now got coordinates 4, 4, and B has now got coordinates minus 6, minus 4. The effect of the 2 that appears in front of the graph is to do a vertical stretch with a scale factor of 2. So my graph is now getting steeper. Now I haven't really got space to do it to scale, but it's only a sketch anyway, so I'm just going to try and make it look a little bit taller as it goes up. Come back down again. There's my point of inflection, my second point of inflection, and my lower point down here. As I say, it's only a sketch. You indicate that you have actually sketched it by increasing the coordinate. The x-coordinate has stayed the same. This time the y-coordinate has changed to an 8. And in this one, the x-coordinate stays the same, and the y-coordinate stretches to minus 8. And that is the graph finished.